I don't want it to be funny anymore, because if you're coughing, I totally understand. If you need to go get some water, feel free to go get some water. But we do have class, okay? Well, I have to teach. All right. So if you're a distraction, you got to get up and you got to go get some water. All right. Then you can kind of listen to the video if it's necessary. All right. So today what we have is we are going to solve what's referred to as systems of equations. All right. And basically what that means is you're going to have two graphs, and all you're doing is finding where the graphs intersect. That is called the solution. All right. That is called the solution. Now, the first part here, though, is to determine whether the solution that they give you is actually a solution. All right, if it is a solution, it will work for both equations. So what does that mean? Look up and see if you understand what I'm doing. I just did -3 plus 1 equals -2. Is that a true statement?
Yes.
Yes. So it works for the first one. All right, now I'm going to plug it into the second equation. So that would be 2 times -3 minus 2 times 1. Does that equal -8?
Yes.
Yes, it does, I believe. All right, so that means, yes, that is the solution. All right, that's the solution. Everybody see what I did?
Yes.
I just plugged in the x value, -3, and I plugged in the y value of 1 into the equation. It satisfied both equations. Keep that in mind. It has to work for both equations. All right? Now let's just take a look at question number 2. So I plug -1, 1 in. -1 plus 1, does that equal 0?
Yes.
Yes, so it works for the first equation. 3 times -1 minus 3 times 1, does that equal 0?
No.
No. So is that a system, or is that a solution? The answer is obviously no. All right, does anybody have any questions or concerns with that? All right, now let's look at question number 3, just to make sure we're good. Does 3 times 1 minus 2 times 2 equal 1?
No.
I don't think it does. So do I even have to check the next one?
No.
No. It's automatically no. All right? So now what I want everybody to do is to check 4 and check 5 while I answer the phone real quick. Yeah. All right. So in this case right here, as soon as it's false or it's not a true statement, we can just write the answer is no. All right? So now let's take a look at question number 4. All right? Does -5, 6 work? Now again, I agree with you. I think it does. All right? I think it works for both. But does anybody have any questions with that? Again, it's just a matter of plugging in for x and y and see if it's a true statement. All right? And I ask you to number 5, so is that true?
Yes. No.
Yeah, I think it works for the first one, right?
Yeah. The second one.
But I don't think it works for the second one.
No, it doesn't.
All right, so that answer is obvious. 5 is no. Is everybody good with that?
Yes, sir.
All right, now we'll leave 6 for later. All right, now what I want to do is I want to look at 7, 8, and 9. All right, when I look at 7, 8, and 9. All right, now, is there a solution for question number 7? No?
Yes.
Why is there yes?
Because they intersect.
Because they cross or they intersect. That's exactly correct. Now, what I'm trying to show you is that point right there, that is the solution. All right, that's the solution. Now, the reason why this is a good representation of why graphing sometimes is not the most efficient way to do this, because is it really possible to tell what that answer is?
No.
There's no way to look at that and say that's exactly this.
Yeah.
All right. If this was the solution, it was obvious, then we would say the answer is 3, 1.
Yeah.
Everybody see that?
Yes.
That's why the calculator is going to help us out tremendously. The calculator will give us exactly what the answer is. All right. But I'll first want to show you how to do it by hand. All right. So there is, in this particular case, one solution. I just don't know exactly what the solution is. Are we good on that? All right. Now everybody take a look at number 8. What is the solution on number 8?
There is none.
There is no solution. Thank you very much. The reason it is no solution is because do the lines intersect? No, they are called what?
Parallel.
They are called parallel. So again, they do not intersect. All right. Now let's take a look at question number 9. Now in question number 9, what I tried to do as I was making this worksheet up is I tried to draw a line, and then I tried to draw another line right on top of it. So how many solutions are there?
Infinite.
That's right. There is an infinite number of solutions, we say. There's an infinite number of solutions. Now, is every answer or is every ordered pair a solution?
No.
No. The solution is the actual line itself. So, for example, everybody look up. Is that point there a solution?
Yes.
Is this point right here?
Yes.
And this point?
Yes.
And this point?
No.
No, because it's not on the line. The line itself is the solution. The line itself is a solution. All right, does anybody have any questions with that?
Would it be the negative infinity, comma infinity, or just
No, because that means it's all of the numbers. All right, the only thing we're looking for, there isn't a solution. There are an infinite number of solutions. Do you hear me? All right, which is different. Do you understand what I'm trying to tell you? All real numbers means it always works for every number. It doesn't work for every number because I just showed you a number that it doesn't work for. So we say there's an infinite number of solutions. All right, we can't list them all. All right, but we can see them all. All right, and it's any point that's on that line. Is everybody good with that?
Yes.
All right, very basic. All right, now 10, 11, and 12. All right, look at number 12 for a second. So everybody should be able to easily tell me the answer to number 12 is what? What is it? One solution, and the solution is?
2.
Right, so we'd say the solution is 2, 2. Everybody okay with that?
Yes.
And 11 we would say is what?
No.
No solution. And 10 we would say is?
Infinity.
There's an infinite number of solutions. All right, I agree. That's very easy. All right. Now, the rest of the time today, we're going to actually find the solutions. All right. And this is what I did in my last class. We did number 13 together. We just graphed the lines, and then we found out what the solution was. So what we're going to do is we're just going to go ahead and knock out 14 together. All right. So in order to do 14, the first thing we have to do is convert it over to the right format into y equals mx plus b. All right. So now, again, listen to me, guys. Here's what I'm hoping you can get better at, and this is what I'm hoping you do. All right? I want to be y by itself, right? So I'm hoping you can say, well, I'm going to take this negative y and throw it over. When I throw it over, that becomes a positive y, and then I have to take the negative 2 and move it over, and it becomes what? Positive. Did I move the x? No, so the x stays. So the answer is y equals x plus 2.
Would it be the same answer if you were to move the x?
All right. Now, for number 14, I'm just going to move the what? X. So I end up with y equals negative x plus 2. So for those of you guys who are smart, you should be able to say, well, obviously the answer is 0, 2. I didn't know it was 0, 2. Tell us. That's exactly correct. They both have a y-intercept of 2. Therefore, that is the answer. But we're going to obviously graph that so you can see it. What? Well, yeah, it's not necessary to do that. Just to me, it's easier. You know what I mean? If the y is negative, I move the y. Right? That's what I'm trying to tell you. All right? That way you avoid a bunch of negatives. Good for you. Yes, the y-intercept. All right? Now, you'll see what I mean right now. So to graph number 1, what do I have to do?
Mark 2.
You go up 2, plot a point.
And then down 1 to the right.
Whoa, 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 whoa. You go up 2, plot a point, correct?
Oh, I was doing the other one.
And then I go from there, what?
Up 1 and then to the right.
Up 1 over 1. And what I just want you to do is just mark a couple of those. And that way you can line things up so it looks good. So I draw my line.
Mark it up.
And there you have. Now I'm going to graph y equals negative x plus 2. So here I would go what? Up 2, and then what? Down 1 and over 1. And then you graph the line. And now what you're looking at is, let's find the point of intersection. All right, and of course the point of intersection is right there. So we would say the answer to this system of equation is what? 0, 2. Very easy. Is everybody okay with that? Any issues? All right, here we go. Let's go ahead and jump down to 17. All right, let's try to graph these real quick. So the first equation is just what?
Y equals negative 3x plus 3.
Beautiful. And the second one is?
Y equals 2x plus 3.
Wow. All right, practice graphing that real quick. Even though, again, they share the same what? Yes, already know it's what? 0, 3. But again, what is necessary is for you to review your graphing. So everybody graph that real quick. So the first equation, I would do what?
Mark 3.
Go up 3, agreed.
And then down 3 to the right one.
And then down 3 to the right one. And then let's graph that line. And then the other one, we have to go what? Up 3. Up 2 over 1. And so now it's clear to see that they cross at what?
0,
0, 3. Yes, sir.
Any time that they have the same y-intercept, that's usually the main answer.
That has to be the answer. All right, that has to be the answer. All right. So what I want to do now is let's do number 19. All right, everybody jump down to number 19 for me. So the first equation is what? Negative x plus 3. And the second equation? 2y equals negative 2x plus 6. So
divided by 2 is y equals negative x.
So now you should be able to see you're just graphing what?
Same 3.
The same line. So we know the answer is what?
Infinity.
It's an infinite number of solutions.
All
right, infinite number of solutions. Now, double check yourself. Shh. Guys, there's so many ways to look at that. All right, I don't want people telling somebody what the answer is. All right, I want them to look up for themselves and figure out where they made their mistake at. That's what I want. All right, if you looked up and said, man, I'm not sure why you got that negative x after you look at it, then we can have a discussion. All right? But again, we're just moving things around. All right? So what I want you to do on one of them is to just go up 3, and then from there go down 1 and over 1 a couple times. And then I want you to graph the line. Now, what I tried to do is I chose the highlight so I could see. All right? And all you're doing is basically doing what? Graphing the same line right over top. All right? That shows that there are an infinite number of solutions. Infinite number of points of intersection. Is everybody happy with that?
Yeah.
All right. So again, your options today are to find a single point, to find no solution, or to find infinite number of solutions. It's infinite number of solutions if they are what? Same line. No solution if they are parallel. All right, never touching is good. Parallel is better. All right. Now, the reason they are parallel is if they have what, though? What makes lines parallel?
The same slope.
Yep, the same slope. So lines are parallel if they have the same slope. They also must have a different y-intercept. If it's the same line, they will have the same slope and the same y-intercept. All right? But of course, all you have to do is graph it, and you'll clearly see what the solutions are. All right? So what I asked my last class to do, believe it or not, is to finish up 1 through 18. Whatever I didn't do with you guys, just do 1 through 18. Kind of a short class, kind of easy. Then tomorrow, I need to make sure everybody brings their graphing calculator, because I'm going to review with you how to graph an inequality, because I didn't do a very good job last week with graphing inequality on your calculator, and also finding the point of intersection on your calculator. What?
I like using
The calculators are awesome. I agree. All right? They're very nice and very important when you take standardized tests. All right, so please finish up. Just try to, those of you guys seriously who need to go get water, feel free to go get yourself some water. All right?
I used my calculator